Alright, hello everyone. This is the 11.6 review video. And in this video, we'll be talking about the ratio and root tests. Just quick summaries for the ratio and root test, starting with the ratio test. There are three conclusions that we could come with the ratio test. So if the limit of n approaches 0, the absolute value of a to the n plus 1 over an equals the value of L. If that value of L is less than 1, then that series is absolutely convergent. If L is greater than 1, then the series will be divergent. And if L equals to 1, the ratio test is inconclusive. Therefore, we do not have a conclusion. So if we do get a value of 1, then we have to see if there's a different test that we can do to prove the convergence or divergence, such as like the alternating series test or like the limit comparison test. The root test is similar to the ratio test, but instead of the absolute value of an plus 1 over an, we have the nth root of the absolute value of an equals to L. And if, like the ratio test, if that L is less than 1, then the series is absolutely convergent. And if L is greater than 1, then the series is divergent. And if it equals to 1, then the test is inconclusive, and you have to go check if there are any other tests that help you find the convergence or divergence. Ratio test is works best with exponents and factorials, while the root test works well when the series, the a and n, is to the nth power. So for an example, for the ratio test, we have the series as a series of 3 to the n over n factorial. Since there is a factorial here, it's a kind of a good indication that we should use the ratio test. So what I like to do is start out with finding the absolute value of n plus 1 2 over an. So if you plug that into this function up here, absolute value of 3 n plus 1 over n plus 1 factorial. And since it's dividing, we could just multiply by the reciprocal. So that would be n factorial over 3n. N plus 1, the n here can cancel out, leaves 3 at the top. N plus 1 factorial is n plus 1 times n factorial, so that n factorials can cancel out, and we're left with absolute value 3 over n plus 1. And then you find the limit of that. And since the bottom here, the denominator goes to infinity, 3 over infinity, or anything over infinity will equal to 0. And going back up here, since 0 is less than 1, see, since L limit n approaches infinity, the absolute value of 3 over n plus 1 equals 0, which is less than 1, then the series of 3n over n factorial is absolutely convergent by the ratio test. Now an example with the root test, we have a series of 3 plus 5n over 2 plus 3n, all with the whole thing to the nth power. Since the entire series is to the nth power, that is a good indication that we should use the root test. So here we have the root test, L equals limit as n approaches infinity of absolute value of n of an to the 1 over nth power, which is the same thing as saying nth root. So we have the limit as n approaches infinity of the absolute value of 3 plus 5n over 2 plus 3n to the nth power, all to the 1 over nth power. This kind of cancels out. And we're left with this portion right here, limit of n approaches infinity to 3 plus 5n over 2 plus 3n. Multiply numerator and denominator by 1 over n. We get limit as n approaches infinity, 3 over n plus 5, 2 over n plus 5. These both go to 0. And we're left with 5 over 3, which is greater than 1. And so we have here, since L equals limit n approaches infinity of absolute value 3 plus 5n, 2 plus 3n, we're going to put the n there, and all to the 1 over nth power equals 5/3, which is greater than 1, then the series 3 plus 5n over 2 plus 3n to the nth power is divergent by the ratio test. And that is basically it for the ratio and root test. Just remember, if you use both of the tests and you get equals 1, your test is inconclusive, and you should try to find another way where you could prove the convergence or divergence.